Okay, this is a little thought experiment that's going to get us going today. You hang a bulletin board over your desk using a string. There's a string. You can see that right now it's like a scalene triangle. The bulletin board is crooked. When you straighten the bulletin board, what type of triangle does the string form at the top of the board? And how do you know? Now visualize the vertical line along the wall that passes through the nail. And what relationships exist between this line and the top edge of the straightened bulletin board? You should think about this for a second before you move on, just as a little way of seeing if you can anticipate what we're about to get into. Now, here it is. If you have this line right here and you put some point above it, there's a special relationship between the points on the perpendicular bisector of a segment and the endpoints of a segment. So you've got this, it's got to be a segment, right? You have endpoints on both sides, and then you draw this perpendicular bisector. You bisect it, and you do it at a 90-degree angle, okay? In the diagram below, on the left, line CD, this line right here, is the perpendicular bisector of segment AB. This is a line because there's no necessarily endpoints. There are 2 points, but these do have endpoints, and that's relevant. Okay, now line CD is perpendicular to AB at its midpoint, making it the perpendicular bisector. It's at its midpoint, and it's perpendicular. Okay, in the diagram at the right, you can see that then CA and CB are drawn here to complete this triangle. Okay, and what do we get? Well, you can see that we have side, angle, side congruence, therefore we have 2 congruent triangles, okay? You should recognize from chapter 4 that triangle CAD is congruent to triangle CBD, so you can conclude that CA is congruent to CB, okay? The point is equidistant from, a point is equidistant from 2 objects, objects being A and B in this case, if it is the same distance from the object. Equidistant means same distance. So point C is equidistant from A and B, okay? And this suggests a proof for theorem 5-2, the perpendicular bisector theorem. Its converse is also true and is stated in theorem 5-3, okay? Essentially, if you have a perpendicular bisector, any point on it will be equidistant from the endpoints of that side. Now this is how the theorem lays it out. Okay, perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, like P, then it is equidistant from the endpoints. PA is congruent to PB. And the converse of that is if some point is not on this line, but it is equidistant from the endpoints of the segment, then it must fall on the perpendicular bisector. So you can draw a line perpendicularly here and it will bisect that side. Yep. So it's an if and only if situation. Okay, so if we're going to apply this now to this problem, what do we get? What is the length of side AB? Well, because it is a perpendicular bisector, we know that AB is congruent to CB, and therefore we can set these equal to each other and solve. Yep. How do we know that it is a perpendicular bisector? We see all of the markings. We see those 90-degree angles. We see that that is an equal length of that, okay? So what do we get here then? We set them equal to each other. BA is congruent to BC, and we substitute in their algebraic measures, solve it out, and we get x is 5. Now we need to plug it back in. 4 times 5 is 20, and you can plug it in here. 6 times 5 is 30, minus 10 is also 20, because they should be the same length. Okay? And that's that big idea. So what about this got it problem here? So what do we get here? Well, if we know that because it's a perpendicular bisector, these segments are equal, we can set them equal to each other. And solving it out, I did the math here, shortcutted it, but we get n is equal to 3. So when we plug that in, we get 15 minus 7 is 8. And that's the same here as if we plugged in a 3 here. 3 times 3 is 9, minus 1 is 8. We get the length of QR equal to 8. Okay, so a park director wants to build a t-shirt stand that is equidistant from the rolling coaster and the space chute. Rolling coaster spaceship shoot. What are the possible locations? Well, we know that if we can find the perpendicular bisector, all of the points that are equidistant from those two things will be right on it, okay, as stated there. So what do? To be equidistant from the two rides, we should connect those in a line, R to S, find the midpoint, draw a perpendicular line from it, and any point that is on that line will be a good location for the t-shirt stand because it'll be equidistant from the rolling coaster and the spaceship chute. Yep, try this one. Suppose the director wants the t-shirt stand to be equidistant from the paddle boats and the spaceship chute. What are the possible locations? Okay, and can you place the t-shirt stand so that it is equidistant from the paddle boats, the spaceship chute, and the rolling coaster? Explain. Okay, so if we, first of all, what do? We connect the paddle boats and the spaceship chute, and we find the perpendicular bisector of that, and any points that are along there will be possible locations for that t-shirt stand. Now, can we place the t-shirt stand so it's equidistant from the paddle boat, spaceship chute, and the rolling coaster? Well, we can do this 3 times. We can do it with the paddle boat and spaceship chute, find that line, rolling coaster, spaceship chute, find that line, paddle boats, and rolling coaster, find that line, and if they come together in 3 points, then we can put it right there. Okay, now similar to the perpendicular bisector of a segment, if you bisect an angle, you get this special kind of congruent relationship too. Excuse me, check it out. So first of all, think about the distance from a point to a line as being the closest distance that it can be, and it's always going to form a 90-degree angle. Okay, so it'll always be perpendicular, right? And that's, you could go from A to this line in any number of ways, but there's only going to be one shortest distance, and that's going to fall perpendicular like that, okay? So the distance from a point to a line is the length of the perpendicular segment from the point to the line. Now the distance is also the length of that shortest segment. So that distance from that point to that line is whatever's that shortest distance, okay? Now, if you then say, okay, what if we have an angle like CAB and we bisect that angle, you have these equal smaller angles here, okay? Then if you take any point along it and you measure that shortest distance, the perpendicular distance to each side, you're going to get the same length there, okay? And you can see here this says 3 units on that little ruler, and that would also be 3 units. So in the diagram, ray AD is the bisector of angle CAB, and if you measure the lengths of the perpendicular segments from D, that length, to the 2 sides, you will find that the lengths are equal. Point D is equidistant from the sides of the angle. So then we have it written in as a theorem, the angle bisector theorem. If a point is on the bisector, now that point S has to be on the line that goes from Q, the vertex, through S and cuts that angle into 2 equal parts. But if that point is on the bisector of an angle, then the point is equidistant from the sides. Okay? And the converse of that is if a point in the interior, in here, because if it's out here, it's going to obviously be closer to that than it is to that. So if it's on the interior of an angle, and it is equidistant from the sides of the angle when you draw those perpendiculars, then that point must be on that angle bisector. Okay, so if and only if situation. So we're going to use this in a very straightforward manner. What is the length of segment RM? Well, if we see that this point R is on the angle bisector, then we know that this portion is congruent to this portion, okay? So, and the first thing we know is that it does bisect that angle because it gives us those angle marks, okay? And we know that all of these lines here are perpendicular because we got the 90-degree angles. Those are things you need to verify. And what do we want to know? The length of RM. We can use the angle bisector theorem, solve for X, okay? Now, it says, how can you use the expression given in RP there? Well, we know they're equal, okay? And we can then, once we find our solution, we can then plug that value in and make sure that we do get those same amounts. So here we set them equal to each other, we solve it out, we get x is equal to 5, and we're solving for Rm, so we say 7 times 5 is 35. We verify it by putting that 5 into the other one. 2 times 5 is 10, plus 25 is also 35. Okay, and let's see, here we got a problem for you somewhere, I'll find it. Okay, here it is. What is the length of FB? You're going to solve this out yourself, and we'll come back in a minute with the answer. Okay, so here I've solved it out. The first thing that we want to do always is we want to verify that we are dealing with an angle bisector, which we are. You see these two marks are the same, and that these lines are perpendicular, which they are. Once we've verified that, we can say we know that this segment must be equal to this segment, so we set them equal to each other. Okay, subtracting 4x from both sides, we get 2x, and subtracting 3 from both sides, we get equals 6. So therefore, x equals 3. And I'll obviously shortcut the math, but since FB, what we're trying to solve for, is equal to 6x plus 3, we can say 6x plus 3, plug in that 3 for x, because remember, this is not the solution, this is just what x is equal to, and we still need to find the length. Okay, 6 times 3 is 18, plus 3 is 21, so that length equals 21. To verify it, we say, okay, well then the other one should also be 21 since we know that they're equal, so we say 4 times 3 is 12, plus 9 is 21 as well. So we did good. Okay, so these lesson check problems don't have answers written down here. I will upload a new video that's got the answers once I get access to the teacher edition of the textbook again. Anyway, hope you made sense of that. You can do your homework in Math Excel and make sense of it all. Good luck.